Hello, Jimmy.
Hello.
Would be funny if it was just the two of us.
That would be very, very funny. Yes, I would love that so much. How are you doing?
Doing well now. Oh,
Hey, everybody.
Hey, Paul.
hello.
How's it going?
Yeah, good. Excited to be here.
Likewise.
Excellent.
Tim doesn't get excited very easily, so you know it's good news.
I'm also eating yogurt, so it could be that.
What kind of yogurt are we talking here? I eat like pounds of yogurt a week.
So Greek yogurt with granola. So
Is it plain Greek yogurt?
plain Greek yogurt.
Yes.
Yeah.
It's my breakfast every day. So we'll give it a little bit to see if other folks join. I'm sure we'll see some other folks.
Is this not very well attended? This SIG
So
meeting?
sometimes we'll have like 20 people in here. It's been canceled for a couple of times because there hasn't been anything on the agenda. You know, sometimes we'll have 15 or 20. It's sort of hit or miss.
Okay. Yeah, cool.
Jimmy, I did bump the KubeFed stuff up in the agenda because I suspect that like the multi-cluster services stuff might predominate the discussion. I kind of view KubeFed more as like just a notice for people. And I didn't want you to get cut off.
Yeah, sure. Yeah, won't take much time.
Hi guys.
Hello. Hey, Josh. Hey, Tim. How you doing?
Howdy.
All right. Well, I think we're probably maybe 30 minutes or 30 seconds out from the end of the grace period, and then we'll get started. Jeremy, I did move the multi-cluster services discussion back in the agenda since I wanted to make sure that we didn't cut the KubeFed updates off.
I saw that. That sounds great.
Okay.
Thanks.
All right, let's go ahead and get started. So we got a few things on the agenda today. First is Jimmy with a couple updates on KubeFed. You've got the floor, Jimmy.
Hello. So I'm Jimmy Dyson. I'm from D2IQ, and yeah, so we're very interested in KubeFed. Very interested in supporting it and moving it forward again. I know it seems to have stalled. So we've recently done some scale testing of it, and we wanted to do some work to kind of optimize that for a larger scale. It fits a lot of our use cases and a lot of cases for other people. Yeah, so we're hopefully going to push a few improvements in there. First of all, trying to figure out what scale it can handle right now, and then figuring out improvements that we can push into it to improve that. A couple of pieces that we've already. Sorry, go on.
I was just going to ask, what if you could tell us like a little bit about any scale testing results you've seen so far, and like what scale are you after?
That's a good question, right? So what scale we're after, we're talking hundreds of clusters and managing thousands of resources across those clusters. And we're trying to figure out the scale that a single kind of kube-fed control plane can handle, and how we have to then figure out architecturally how we scale that with probably multiple kube-fed control planes, right? So we have to figure out that right now. Right now, the initial kind of testing we did says that, like, with a reasonably small amount of resources, I haven't got the details to hand, can easily handle like 50 clusters and a few thousand resources. So it's decent right now. It's good enough for a lot of use cases, but we'd like to expand that. I can show you. I can check. I'll probably share some of those details after this. I haven't got them with me right now, but if anyone's interested, I can share those docs.
Sure, I think that would be interesting. One thing I noticed on the agenda here is a question about cloud resources for use for that. Is that accurate?
Yeah, so one thing I wanted to first of all investigate, there is a scale test in there right now, and that I just want to see what people think of the state of that. Maybe if anyone's interested in discussing the current state of that and how we can expand that scale testing that's already there, and then if there is access to any cloud resources that we can use to do that, that would be really great for the project.
Yeah, so we never got we never sort of pierced the veil on testing with cloud providers. Absent any access to cloud provider resources, one thing you could potentially look at is using Kubernetes and Docker as the project name kind to simulate those like receiving clusters where each one of those is just running in a container.
Yeah.
So that may be actionable.
Yeah, so that's one of the things that we're kind of doing, that we started doing our scale testing with, as well as with various cloud providers. Some of the things we wanted to take into account that does affect the scalability of the things like latency, network latency, and going across across the internet, not just all local. Some of the controllers that we looked at, the latency affects, for example, cluster health status. One single cluster having a 3-second latency will affect the cluster health status for every cluster, for example. So there's things like that we need to do some. It's another part of my points in here. We need to do some refactoring of the controllers to take that into consideration. Okay, so there's the other part. So the other part is we need to obviously, and we've already started putting PRs in for this. Hector, thank you for what you've done for exposing metrics in KubeFed, which is a good first step to start to quantify, any improvements that we make. And yeah, looking through the controllers and looking at how we can, say, redesign those. Want to migrate over to controller runtime because of some of the niceties that we can take advantage of there, that kind of, especially around metrics, especially around other things, to simplify the code base as well and provide the same capabilities. And trying to think about how we cache a bit more effectively and a bit more cleverly, really, around what resources we're watching in target clusters, to try and reduce the resource usage. They're the kind of things that we're thinking about right now.
Well, I'm very glad to have you and the other D2IQ folks involved. Let me take this opportunity to say that that KubeFed needs more maintainers. So if you're interested in participating, or like, maintainers a lot of responsibility, but if you're just interested in contributing, don't hesitate to reach out, I guess, to me or to Jimmy.
Yeah, absolutely. We want more. We actually think this project is really great, and I say it fills so many use cases that we want and simplifies a massive architecture. And I think, if we can get more contributors, then that'd be great. I think what I'd like to do is say, through this project, I think we'll get more take up from it as it moves maybe to beta or something like that. But we want to stabilize it before we go to beta, and then hopefully we'll get more take up.
That seems to be like the Zen cone we'll all meditate on forever, is how do you get people to use something that has the alpha label on it. Absolutely critical to getting feedback on things that are alpha, but also very scary for most people.
Yeah, absolutely.
So there's this, sorry to be contrarian, there seems to be this general malaise around KubeFed. Even at KubeCon, people were sort of all not super excited about it. I would love to hear, maybe not today if we don't have time, but what specific use cases are you trying to address with it that don't have other solutions? I know full well that other solutions are few and far between right now. But I'd be curious to hear sort of very specifically what sort of problems you're tackling with it.
Sure. Maybe now's not the right time, like you say. We can do that in the future. And there are absolutely other ways that could be tackled. I'd say one of the reasons for us using it was there was something that worked right now, right? That's what we're approaching. We're going, there's something that works right now for a number of our use cases. Doesn't fulfill all of them, but let's see how, if we can go work with that and then, you know, build on top of it rather than building something necessarily from scratch. There don't seem to be any fundamental issues with it right now that block us from expanding it to further use cases. But yeah, we can absolutely discuss that maybe another SIG meeting.
So that probably covers that first bullet point. There's another one on there about resuming releases. You want to talk through that one?
Yeah. So I think part of again getting the project going and getting the project getting maybe more impetus behind it, starting to put out more releases regularly, like maybe even every couple of weeks, something like that. There will be features going in, there will be bug fixes going in, may help to build a bit of momentum behind it again. That's kind of the main reason for that. I mean, there are some bug fixes already in there that users are reporting that are actually fixed. For example, what is it, AKS uppercase host name in kubeconfig. You can't join an AKS cluster at the moment, and this is already fixed in master. So just releasing it fixes someone's use case, right?
So the sort of the point at which the momentum kind of dissipated behind KubeFed, there had been a lot of interest from the people that were involved at the time in like taking the project to beta by KubeCon at one point. When we resume releases, I think the last release we did was like was labeled in a way that communicated it as a beta release candidate. I think we probably want to go back to version numbers that are clearly alpha. And like I am all about stepping back from the brink of beta until there's like a real feeling from the people that are involved currently that it's something that would meet people's expectations as a thing called beta, that like has enough of like an energetic force and momentum behind it that you know, we can responsibly call it beta. How do you feel about that, Jimmy?
Yeah, absolutely. I mean, that's what we're doing. We're calling it alpha, as we're, you know, for our users. So I'd absolutely much rather report this or release this as an alpha than a beta. It's not in beta quality at the moment.
Mm-hmm.
Yeah.
Okay.
One thing I would say, just to this, just come back to what Tim said a second ago about other solutions to the same problem. There are, and I think this is another part of maybe KubeFed, in my opinion, why it's so great, is that actually it simplifies a lot of use cases for maybe less technologically advanced users that don't have necessarily other capabilities on GitOps with these other things, that they don't have that. And this is the sweet spot I see for KubeFed right now, is managing a large set of clusters, trying to get them as heterogeneous as possible, with the same resource going out in a simple way through the Kube API, that they get that and they don't have necessarily more capabilities in other areas to implement maybe a more complex solution, I guess. That's the kind of sweet spot we see for it at the moment. And that might be something why we don't get so much community feedback, because communities tend to like complicated techie things in my experience, rather than something that is too simple sometimes.
What kind of time frame were you thinking of for a next alpha release, Jimmy? I think there have been a couple things that we merged this week that should go out if they're merged.
Yeah.
One of the things that, like, just my own opinion here, that I think like sort of complicated people's ability to use KubeFed in the past is that like there was at least my own subjective view, maybe a desire to have like releases be more meaningful than this is what's done. For stuff that's in alpha, I'm personally very happy to release it every week if there's things happening. So I'd be completely on board if you all wanted to do like weekly alpha releases while things are getting merged. Like what kind of schedule had you considered?
Well, completely honestly, we haven't. I'm happy to cut alphas whenever, right? So yeah, weekly would be great. Maybe fortnightly, who knows? But we haven't actually considered a release schedule yet. It's just what I say that I really feel that if we get this going, I think there'll be more behind it, and getting alpha releases out will also allow us to quantify between releases the improvements that are made and see progress. So yeah.
So maybe something to think about, as a takeaway. Maybe you and Hector and myself can talk about when the next time to do a release would be. I think some of the metric stuff that Hector's working on is still in flight, so maybe after that settles, might be a good time to start doing releases again.
Yep, sounds good.
Yep.
Yeah. Hector, do you have anything else to add? Just
Well, no. Basically, most of what you just say regarding metrics, I think is very interesting, and it will be one of the things that we can add in this release that make a differentiator for just bug fixing. So that's something it could help in the future to scale better.
Great. Well, thanks for the updates. It sounds like we're talked through on those two things. Can we move on to the next agenda item then?
Yep, all done. Thank you very much.
Thank you. Okay, Jeremy, you're up next with multi-cluster services proposal.
Awesome. Yeah. So I'll share my screen here in a sec, but a few of us at KubeCon San Diego got to talking basically about multi-cluster services and just seeing that more and more people are obviously using multi-cluster. So how can we, what can we do to make it easier to kind of consume those services, deploy across clusters, that kind of thing. So we've continued to kind of think about that and work on it, and we put together this doc with a proposed API and what that could look like. So let me share this now. And I'm going to share the doc. I would love if anyone reads it offline as well, comments, feedback, input, hugely appreciated. Just a sec here. It looks like I'm going to have to quit and sign back on to share the screen here.
It happens. Go for it. Does anybody want to hum some hold music? I'm looking at you, Jimmy.
Yeah, I could sing for you.
I was all on mute here. I was singing the Girl from Ipanema.
Sorry about that. Looks like I had not given permissions. All right. Now sharing for real. All right.
I see it.
See the doc?
Yeah.
Yes.
Right. Great.
Yeah.
Yeah, so like I say, basically all we want to do is introduce a common API for multi-cluster service discovery across the Kubernetes ecosystem. And it'd be great if, we're going to talk about what maybe an example implementation could look like, but really the idea is about the API and kind of leaving room for other implementations. But just so we're on the common ground here, and I think we've kind of come up with a couple terms that we've been throwing around. The first one is definitely a placeholder name. It's not, I think, what we necessarily want to call multiple clusters, but we've just been calling groups of clusters superclusters, just to have a way to talk about them. And then the other thing I'm going to probably mention a lot here is the MCSD controller, which is a hand-wavy, this is the implementation, whatever the implementation is, but basically whenever there is some behavior that needs to happen somewhere, the MCSD controller will be responsible for that. So we've been looking at two primary use cases here, and I'm just going to kind of focus on headings until we get to code. The first one is kind of the simplest case. Just you have different services in separate clusters, and you want to consume them across clusters. So I have cluster A with one service and cluster B with another workload, and the workload in B wants to consume the service in cluster A. That's kind of the simplest multi-cluster case. Maybe they're managed by different teams, different orgs, and you just want a way to expose them. And then the second one is single service deployed across multiple clusters. So this could be, for fault tolerance or, redundancy. I've got a few clusters that all look similar, and I've got the same service in each cluster, and I want to expose all the services and basically consume them from anywhere.
So can I just ask a question about that quickly? Is in that in that topic, do you view each of those instances of the service as fungible, or are things like stateful services with sharding in play too?
So we are assuming that the API for the service is those services. Yes, so basically they're fungible. The API for the service is all the same. Now, whether or not you could seamlessly move those services between clusters and actually move data and everything with them, that's we're not really getting into that. But assuming basically we're making the declaration here that that a service controlled by your MCSD controller in a namespace is the same as any other service with the same name in that namespace in any other cluster kind of connected to that MCSD controller.
Got it. Cool.
And I think I called out something similar when I reviewed this, Paul, that headless, stateful set sorts of services aren't really well addressed yet.
Yeah.
Right. Yeah. What would that actually look like is a different story.
Yeah, I mean, workloads are handled at another layer, and I'm presuming this proposal doesn't really deal with the workload portion of this.
But ignoring the workloads, though, like when you set up a stateful set, often you will have a host name assigned to the endpoints within the service that goes with it. And if I set that up in two different clusters, I might have the same endpoint name in two different clusters, and I don't know that those things are mergeable.
Right.
Ooh, ouch.
Right. Yeah.
We would need some way to exclude endpoints, because I'm just thinking about what I would want to use this for. And that includes manipulation of endpoints, which obviously wouldn't work if we had the identical endpoints.
Well, I mean, I think maybe let's let Jeremy focus on the most common case, and then we can address, I think the endpoints with host names is a more niche case. It's real. We need to deal with it, but I think it's like the 5% case, not a 90% case.
Yeah, I think stateless is a perfectly good place to start. And probably we can't do stateful right without doing stateless right first.
Right. Yeah, we've mostly been thinking about stateless to start, but whatever we do here, obviously we would want to be able to extend to stateful. I think that would be one of the goals. We don't want to have a different way to, an entirely different way to do stateful if we could avoid it.
Yeah.
Okay, so yeah, high level, those are the use cases. So basically what we're looking at here is creating a new CRD that we've been calling service export. that you use to specify which services should be exposed, and make them available to the other clusters that are connected to that controller. So this kind of assumes, also hand waves away some kind of registry that controller is using. Whether it's you manually configure everything or whatever you want to do. That controller has some list of clusters that are all registered together. So you'd create a service export, and I'll jump to that in a second. And then on the other side, there would be a new CRD. At least for now, we're looking at we've been calling imported service, which behaves a lot like service, but for those imported multi-cluster services. And we're basically thinking that in the simplest case, we could extend something like kubeproxy to understand imported services and just kind of make them work using the same kind of proxy fabric we have today. So I'll jump down to the service export to kind of show how simple we're hoping this can be. But basically, a service export is a simple CRD that you'd create this resource in a namespace with the same name as the service you want to export, and then it would just be exported. Where maybe there's some status that needs to be on the service export to communicate whether or not it's been picked up, but basically this is a name map resource, and once you create it, this service is exported. Now what happens when you export this, and I think this is an important part of the API, is we want to make it just like consuming cluster IP services today. So this is your in-cluster experience just extended to multiple clusters. And so we've been looking at something like a supercluster IP, multi-cluster IP, that would be a VIP that gets created because of that imported service resource in each cluster connected to your controller, that you could access just like cluster IP today, and then kubeproxy or whatever the implementation does could route traffic to the endpoints accordingly. And those endpoints might be in a different cluster, they might be in multiple clusters, or maybe they're in the same cluster, but you're potentially using this for future proofing, and you just want to know that you can add endpoints from other clusters for failover. In terms of DNS, we're thinking, again, it looks just like you see today with in-cluster services, except that instead of a service.cluster.local name, it might be a service.supercluster.local name. If you connect to that name, and that's probably how we recommend people use this, it would resolve to that supercluster IP within your cluster, and then you would, again, just connect to endpoints that are anywhere within that supercluster.
Can I see if I can summarize the mechanics so far?
Absolutely.
It seems that the knowledge of membership in the supercluster is sort of reserved for the controller, where that might come from any number of sources. But in the cluster that is exporting the service, you make an exported service that in turn results in the controller somehow creating imported services on the other members of the supercluster, and those are using the virtual IP allocated for in the space of IPs for the supercluster services. Is that right?
Right, exactly.
And then as a hypothetical, one implementation could be kubeproxy becomes aware of these things and presents them like they were services in cluster, right?
Exactly. Exactly, that's right. But with a different name that lets you kind of declare that I don't care where this service is located. So we're not trying to repurpose cluster.local. This would be a different way to access it that lets you just specify you don't care. Now, also this is purely within clusters, so this is like a pure Kubernetes implementation that we've been talking about, and we haven't really thought about what this would look like if you tried to consume that from outside of clusters, from on Kubernetes resources, but within Kubernetes, yeah, you just described it exactly.
Okay.
Yeah.
So
Go
How
ahead,
does,
John.
with a group of clusters, how does, assume that we have a group of clusters and each one of those clusters has several exported services, how does synchronization work?
So what we've been thinking here, so first of all, in terms of governance, I think I kind of brushed on it, but it's important to really hammer. We're making the assumption that this is that there's identity at the namespace level. So if a service in any cluster has a given name and is in the same namespace, probably with some exceptions like kube system, default, and maybe a few others that are common depending on which projects you're using. But for the most part, if you have a namespace and you have a service with the same name in that namespace in multiple clusters, that should be an equivalent service. And so if we create an imported service in a cluster because the controller sees the export in one cluster and creates it in another, it would be with the same namespace or a same name in the same namespace. And so, if we're assuming that you have access to, if you want to like read the service or anything like that, you'd need access to resources in that namespace.
So each cluster is polling the other clusters for exported services?
So we've kind of specifically not described how this needs to be implemented. So that would be the controller. So, it could be that your controller is, some controller running in one of the clusters that watches all the other clusters and synchronizes endpoints, or it could be that you have some kind of gossip thing going on and each cluster's got a controller that's responsible for watching each other cluster. We've kind of not really been prescriptive about that because it could impact like, latency and performance, but I don't know that it really impacts the API.
Yeah, so we have been looking at this from the Submariner project, from Lighthouse, which is a sub-project that we have doing something very similar to what you are defining here. And we are doing, currently we have like a central controller that actually depends on KubeFed, but that's like a prototype just to test. And we are moving towards like a distributed implementation that will have some central place where the clusters exchange the information about the exported services. And then we are looking even at other possibilities to make it still more resilient and distributed. But yes, as you said, there are many, many ways of implementing that.
I think that's actually really important at this phase, that we agree on how we want it to behave and what the API looks like, and then we can go off and play with different implementations.
Yeah, agree. I think this is like a space where having different implementations will like eventually rule the day.
Yeah, and I have a comment about the API that you are proposing. I don't know. I have the feeling that maybe something that will let you export several services at once, like having a selector instead of just having the name for the service and then that service is exported. Maybe you want to export several of them based on labels or something like that. It will be more similar to a service selector or a pod selector on a network policy.
So yeah, we've kind of been thinking about that. That's a really good point for discussion, I think, because this model assumes name mapping. So it would be one service export per service that's exported. We've kind of been thinking that if you wanted to do like, export every service in this namespace or export selected services that match a label, you could, it wouldn't be hard necessarily to write another controller that just watches services and creates the exports automatically, matching those rules. But I think that's a good point. It would be good to get feedback too. One thing that may or may not matter is that it may be more difficult to expose status on the service export about a specific service if it actually maps to multiples. Maybe not. Maybe the status that we've kind of put together a few examples here, but maybe they're not hugely valuable. So I think this is definitely something that's worth talking about.
So one question that's running through my mind is like, is it even a requirement that like the composition of the supercluster be visible in the Kube API?
You mean like all of the other clusters be visible in the Kube API?
Right. I'm sort of asking like, do you even necessarily need something like cluster registry, or is that not even a requirement?
No, so I think the way we've been thinking about it, that's kind of a separate problem. We've kind of isolated that from how this works. So if your implementation had a specific cluster that was responsible for performing the synchronization, that cluster would probably need a cluster registry, but there's no real reason why any of the other clusters would in that kind of fan in, fan out model. If you had a fully distributed model, then yeah, you'd probably need a cluster registry in each cluster so that each cluster would know who to talk to. I think we've been kind of leaving that up to the implementation. I mean, realistically, there's also a case where everything just lives outside of your clusters, or there's some other cluster that's its only job is to perform this task, and it's not actually part of that export import system, right? So we've kind of been leaving that out, but this implementation doesn't actually require that any of the consuming clusters know about the other clusters, just about the services.
So then is it, and maybe this is explicitly present in the doc, I haven't found it so far. So like by defining superclusters as groups of clusters that have a high degree of trust, it sounds like that is sort of, maybe you could define as a characteristic that like anything that you make an exposed service for, like should be consumable within the group that constitutes any given supercluster, right?
Yeah.
That like there isn't any notion, as far as I can tell in this, of like go here but not there. Right.
Yeah, we're kind of assuming there's a high degree of trust, and then one of the things that is kind of spelled out here in another section on governance is that basically that high degree of trust also needs to be in some kind of space where you can make the statement that like this namespace is consistent. Like we make the assumption about that namespace sameness. This kind of trust area needs to be able to enforce that.
Gotcha.
Does that imply that we're talking about a group of services that have a degree of trust, not a group of clusters?
I think probably, I don't know that then you need to have trust over the namespaces, but if you can't access a namespace, like I guess you'd want the same namespace controls, access controls across all of your clusters. In this case, I think we're assuming similar trust as services running in different namespaces in the same cluster. I think that's probably a good way to look at it.
Yeah, I think the cluster problem is simply if I am relying on the name, which is not cryptographically secure, obviously, then anybody who controls a cluster can join my service. So I think I have to trust the admins of all my clusters. Or I have to have a controller that's smarter than simply merging by name.
Right. And I mean, it's also possible that we haven't talked about this, and maybe we want to leave this out of the scope, but it's possible that your controller does do smarter things. That an implementation could have more rules.
And in fact, maybe it's worthwhile to position this as there's actually two parts. There's sort of the Gazintas and the Gazautas. On the Gazautas side, we've got this thing that represents a global service or a supercluster service. And if we all agree that that's how we're going to consume supercluster services, then cool, we can lock that down. And then the Gazinta is how do you convert a cluster service into a supercluster service? And that's the export. And I guess it's interesting to think about you could have cryptographically strong controller. Like you could require to present a certificate that allows you to join that supercluster service if the controller wanted to be implemented that way, I guess. Does that make sense?
Yeah, it does. I find it hard to decouple discovery from policy.
So if I have a supercluster composed of 3 clusters, and each of those clusters I'm serving the same stateless service from, and I've got like a load balancer in front of all 3 of those clusters, can I use exported service? Do I need to use exported service?
I think it's exported service here represents the inside the shell routing. The east-west, I guess, is with the sort of common vernacular. That's not exactly right, but service in cluster A, service in cluster B, anybody who's within the crunchy outer shell can talk to that service and have them be merged. I don't think this addresses in any way the publishing of a service beyond the edge of the clusters, right? The same way that kubeproxy doesn't handle that case.
Right.
So there's no implied, like, so let me put it this way. The virtual IP that's allocated is not usable outside the cluster or outside the members of the supercluster, right? It's on cluster only.
I would not say that quite as strongly. Like implementations can differ.
Right.
I can imagine an implementation that was based on a real load balancer.
Right.
And I can imagine implementation based on kubeproxy. So,
but there's no promise.
Right. We're making the statement that it needs to be available within clusters. We're not making the statement that it can't be available outside the cluster based on your implementation.
Right. Just like today, some people set up static routes or dynamic routes into their service cider by routing it through various nodes of their clusters, which is questionable, but people do it. You could do the same thing here.
Mm-hmm.
Right. But one of the things that we're also kind of talking about here a little further down is that by kind of targeting that east-west, which as Tim says isn't maybe 100% accurate in terms of terms, but when you're from Kubernetes to Kubernetes, you can take advantage of more, knowledge about the source and destination. And so, we've mentioned things like topology keys and session affinity. And without digging too much into this right now, because that's a whole other thing that I would maybe encourage people to read up on offline. But there's some new work around topology and what that could look like. Whatever that ends up being in Kubernetes and service topology, we probably want to have a similar thing extend across clusters. So if you have clusters that are maybe somewhat separated. You probably don't want, with some kind of high cost between them, you probably don't want traffic to unnecessarily go between them. So whatever we end up doing for in-cluster services, we probably want to extend as well. And that's, information that you might not have when consuming across a load balancer or something like that.
Mm-hmm. So one of the use cases that folks have expressed an interest in having solved for them is like automatic failover from an on-cluster service to a redundant service in another cluster. Right. Is that something that you could do with this iteration of the proposal?
Yes. Well, so kind of 2 parts to that question. So the way we've been thinking about it, I guess I would say exactly how that would work kind of would depend on where those clusters are. I think with this iteration, if we're talking about, the current service topology API, if those clusters are co-located in the same topology boundary, if we just did the simple kubeproxy IP tables implementation, the service would kind of always be backed by both clusters. But if you had a cluster that was in a different topology boundary, then you might not, then it wouldn't fail over unless the first one was down.
So I'll also add there's within SIGNet, which this will have to go to, within SIGNet there's a separate discussion about whether service should have a concept of a failover selector or a failover mode, which is only used if there are no endpoints in the primary mode. How that intersects with topology isn't defined right now. It's pre-KEP, but I understand what the idea is about. I think to go back to what you asked, Paul, like what are the actual requirements here? Is it that you want to include some endpoints that are outside the cluster, or that you want to include them only if the in-cluster endpoints are not available, or in supercluster endpoints?
Yeah, I think probably the second one is where like most people would sort of naturally be thinking. That's definitely the flavor that I've heard more than anything else when it comes to this use case.
Yeah, and the
use case, very popular use case. And also
the example that sort of resonated most simply for me was if my service is down, I want you to hit the global 5.0 whatever service or 4.0 something service, which will return a pretty page instead of a black hole. Oh, okay. I guess I understand it when you put it in terms like that.
Yeah. Yeah, they're pretty different behavioral modes, right? Like, okay, this is very interesting. I wonder, like, what next steps do you imagine, Jeremy et al.?
There's a lot of comments on the doc already, and I don't think that we've really scratched the surface. I think we need more people to look at it and think about it, ask good questions like this failover stuff. We haven't really talked much about scalability and the problems that this will bring, absolutely. And I think we can't really have the conversation about services without talking about network policy.
That makes sense. Do you think you'll present this at SIGNet anytime soon?
Yes, I think we probably need to. I think we're talking about concepts here that would need SIGNet involvement for sure.
Absolutely. SIGNet doesn't meet this week, it meets next week. So that might be a good timeline. We really wanted to get the multi-cluster lens on it first before we bring it to SIGNet, who will take it apart from a networking point of view.
I certainly think this is like it's an easy to digest, like good starting point conceptually. Like I'm imagining that there's a lot of stuff that you like explicitly in your minds like ignored or called out of scope. So I think it's a good starting point. I guess my question might be like, well, I won't even ask it because it's too soon. So I'll just keep everybody on the edge of their seats.
Thanks, Jerk. No, it really, you know, like I've seen a prototype of this thrown together. The ideas here aren't particularly earth-shattering. I think the main goal here is to get consensus on like, this is how it should kind of work. And if everybody assumes that it works the same way, then we can all explore different topics, different ways of implementing and different second stage problems here, right? I've talked before about this idea of the adjacency of the possible, right? We don't really know what's possible until we step into the next room. So I hope that this enables us to sort of at least poke our head into the next room and see what the next door beyond that might look like.
Right. Yeah. Like if we had kind of had some kind of consensus around what it means to expose a service and what it means to import a service, then we can start exploring like what kind of advanced things can we do with the controller and like, you know, what kind of policy can we build on top of that? And yeah, it really kind of opens up the discussion. But reiterating what Tim said, I think more eyes on this document would be great. More input, raising the questions that we've kind of raised here, kind of figuring out what we haven't thought about.
I guess one thing that like people will probably inevitably ask about anything in this space is like what are the failover characteristics or high availability characteristics that you'd imagine are sort of baseline requirements for the controller implementation?
So
Does it
Jeremy,
have to
you
be HA across 2 clusters for the controller, for example?
So I'm loath to say that the controller has to implement anything, but the doc did talk sort of very briefly about timing out non-responsive clusters. Jeremy, do you want to talk about that, the leasing stuff?
Yeah, we didn't really get to it in detail, but we've been thinking that there would be, we basically associate the imported endpoints with a lease, and it would be the controller's responsibility to keep that up to date. And so if the lease expired, like we stopped hearing from one of the clusters, we'd remove those endpoints. So if anything happened to the controller and it wasn't able to keep things in sync, there would be something at each cluster level, regardless of how the controller is implemented, centralized, distributed. However, there'd be something at each cluster level that would clean up imported services if it stopped hearing from things, so that we wouldn't get, you know, stale endpoints living around forever.
Mm-hmm.
I think that's definitely something that needs to happen, and then we need to kind of agree on at least high level what those characteristics look like.
I'm getting kicked out.
Okay.
Yeah, I think that would be interesting to talk about in a future discussion. Certainly, like one of the feedback that we heard most in the community around the KubeFed design, which is like a push model, is that it's like that mode is inherently vulnerable to like a single point of failure. Right. So what I'd expect like a lot of like folks to ask before they could adopt this in the enterprise would be, how is the controller going to be made HA across clusters, so that, you know, if that thing goes, if one instance of that controller goes down, another takes over.
Right. So,
yeah.
But do we decide that that's something that needs to be, you know, part of the export import API, or is that a separate thing? Because I think there might be different answers depending on how.
I don't think it necessarily touches the API, but it's sort of like like it's certainly something that people will view as like a requirement of any real implementation.
I'm gonna argue that for at least the initial proposal, we should specifically say that's out of scope.
I agree.
Yeah, I agree with that.
Actually, a very hard problem to solve.
It is.
Yeah, I think we need to be able to hand wave to convince people that a good solution is possible. We don't need to have the solution.
I've just realized we're like 10 minutes or more over. So maybe we can call this a good discussion for now. I will post the recordings and maybe we can just get an advertisement if you're going to present to SIGNet next week and continue discussing in our next SIG Multicluster.
Absolutely. That sounds great. Yeah, please take a look, everyone. Love your feedback.
All right. Thank you very much, everybody. Have a great day.
Thank you.
Thank you.
Thanks.
You too.